Hello and welcome. Before enrolling in this course, how about you watch this first? So first of all, what do you need before enrolling in this course? Well, since we spent quite some time deriving equations with calculus and algebra, high school mathematics is recommended. Also, you'll need some basic physics knowledge. You can watch the videos provided for free to see what I'm talking about. This course is for current aerospace engineering students or maybe professors looking for support with rocket propulsion, or anyone who just want to learn rocket science for fun. First of all, if you're looking for basic knowledge or history lessons about rockets, just skip ahead. This course is not for you. This course focuses on rocket propulsion with rocket performance, a thorough dynamic analysis, how to design a rocket engine for a specific mission, and we'll take a look at different electric propulsion systems. This course also contains examples and also quizzes at the end of each section to help you test your knowledge. You should also know that this course does not contain orbital mechanics. This only focuses on propulsion. My name is Sadok and this is my rocket science and engineering course. So in the previous video, I've been talking about something but never really explaining it, and that is thrust. So one might ask, what is thrust? Well, to answer that, we have to ask ourselves, how do rockets work? Well, rockets are based on a simple law, which is Newton's third law of motion, which states that for every action there is an equal and opposite reaction. How does that apply to rockets? Well, as I said in the previous video, and if we consider a chemical rocket here, so we're gonna focus on chemical rockets and specifically on liquid fuel rocket engines. So, as we said in the previous videos, fuel and oxidizer are considered propellants. So, these propellants will mix together inside the combustion chamber in here, and as you see in here too. So, they will mix together and then they get ignited, so they will burn, and therefore after they burn, they will get heated up. After heating them up, now they will vaporize and we've got hot gases now inside that combustion chamber, and due to that hot gases and due to that great amount of heat that was transferred, due to the great amount of heat and the great temperature there, the really high temperature there, now we've got a high pressure. And so these hot gases, those hot gases inside the combustion chamber will try to get out through that nozzle, because the pressure or the ambient pressure, the atmospheric pressure surrounding that rocket is less than the pressure inside that combustion chamber. So the gases will try to get out. And now we're talking about exhaust gases. Now, once those exhaust gases leave the rocket or leave the nozzle, we're talking about an action here. So that is the action. The action is the gases being or getting out of that nozzle. So as they try to come out of that nozzle as an action, we will get a reaction, which is of course the lift up of the rocket. And this is basically how rockets work. Now, when we talk about rocket science, there are four fundamental parameters, and there are thrust, mass flow rate, specific impulse, and weight flow rate. We're gonna start off first with thrust. So, what we should say, what is thrust? So, the good question is, what is thrust? So, thrust is the force produced by a rocket propulsion system acting upon a vehicle. In a simplified way, it is the reaction experienced by its structure due to the ejection of matter at high velocity. It represents the same phenomenon that pushes a garden hose backwards or makes a gun recoil. It is a reaction and action thing, or it is of course based on Newton's third law of motion. So if thrust is a force, and we know that force is of course, according to Newton's second law of motion, is equal to ma, the mass, times the acceleration, or in other words, it is the change in the momentum over time, or the time derivative of the momentum. And we know that momentum is of course the product of the mass times the velocity, and therefore we're talking about the time derivative of the product mv, so the mass times the velocity. Now, in rockets, the mass of the propellant is changing, but the velocity, VE, the exhaust velocity at which the gases are exiting the nozzle, is constant. And we will see why is that. We will see why it's constant, why it's not disturbed. So the velocity is constant, and we've got a changing mass, and therefore the thrust F becomes the time derivative of the mass times the exhaust velocity of the gases, and the mass